Da-dan, 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 da-da-da-dan. Once again, we're back with the Pink Panther Pink, and once again, we're talking about exponents, and this time, instead of talking about exponents and multiplication, we're going to talk about exponents and division. Okay, and so once again, I've got Caitlin here to help me out. So let's go ahead and get started. Let's talk about exponents and division, but let's do it first without any actual exponents. Okay, so let's take, well, actually, we'll start with exponents, but we'll break it down to what it really means. What we're talking about tonight are things like x to the third power divided by x to the second power. All right, so let's think about what that really means. The top, all the third power really means is repeated multiplication, right? So this is x times x times x. The bottom, on the other hand, x squared means what?
X times x.
Right, x times x. So if I wrote it out like this, we know that whenever we have a fraction, if we find something on the top and the bottom, it can cancel out. And what we're really doing when we cancel out is we're dividing through by a pair of x's. So this is becoming 1 and this is becoming 1. But we can also cancel out these x's. So this is becoming 1 and this is becoming 1. Not x to the first, actually 1. So on the top, what do I get when I multiply this out? I get 1 times 1 times 1, which is
X.
X. And on the bottom, I get 1 times 1, which is just 1. And is there any sense to even bother dividing by 1?
No.
No, it's just x. All right? All right, let's do another one. This time, let's use a number. Let's use 4 to the fifth power, and let's divide by 4 to the third power. Well, again, without getting into the rule of what we're going to do here, how about we just multiply out what this really means? The top means what?
4 times 4 times 4 times 4 times 4.
And the bottom means?
4 times 4 times 4.
Okay, sorry, that's supposed to be a times. All right, and so once again, if we go ahead and cancel this, I can cancel this 4 and this 4, and they'll both be 1. I can cancel this 4 and this 4, and they'll both be 1. And I can cancel this 4 and this 4, and they'll both be 1. And what am I left with? 4 times 4, or 4 to the second power. Or we could go ahead and evaluate that now. That's equal to what?
16.
16. Either one would be fine. Okay. If it just said to simplify the exponent, I'd leave it like that. If it actually said to simplify it all the way, we'd go ahead and finish it. Now, you could have multiplied 4 to the fifth power. I don't even know what that would be. 256 times 4 would be 1,024, and then you could divide it by 64 and cancel and cancel and cancel and cancel, and guess what? You'd end up with 16. I don't recommend that way. Now, let's take a look at and see if we can figure out a pattern here. All right? I want you to look at just the exponents, Caitlin. All right, so here we had 3 divided by 2, and we ended up with x to the first. Here we have 5 divided by 3 of them, and we ended up with 4 to the second. So what do you think we're doing with the exponents?
Subtracting?
Right. So what we're really doing is we're subtracting the top exponent minus the bottom exponent. Okay? And that's exactly what happens when we cancel. All right? So let's try these same problems again. X to the third divided by x to the squared is really equal to x. Let's use the Pink Panther color. Hold on. Okay? What we're really getting is we're getting x to the 3 minus 2 power, which is x to the first. And down here, we're really taking 4 to the fifth power, and we're subtracting 3. 4 to the 5 minus 3, and we know that 5 minus 3 is 2. That's it. All right, now, when we put this together and we did multiplication last night, it wasn't too terrible, okay? It's going to be a little harder when we're doing division. So let's start with a question like 5x to the third power and divide by 10x. All right, so this isn't too bad. First, x cubed over x is going to be what? 3 minus, remember there's a hidden 1 right there.
Oh, 2.
Yep, it's x to the 2. Okay, and then 5 over 10, be careful, we're not subtracting now. This is just good old-fashioned division. The 5 and 10 cancel like they normally do. What can you take out of 5 and 10?
5.
Yeah, and you get 1 and
2.
2. So you're going to get 1x squared over 2. Most people would just say x squared over 2. So just like with the multiplication questions, we got to remember with just plain old regular numbers with no exponents, we still got to multiply and divide like we normally do. But then we also need to apply these exponent rules for the harder ones. All right, now we're ready to try something different. Suppose we had 12x squared on top, and on the bottom we have 20x to the 5th power. So where the bigger power now is on the bottom. Well, it turns out we're going to do the same thing. So let's start with the numbers this time. Let's take care of 12 and 20. What goes into 12 and 20, Caitlin?
4.
4 does, good. You take a 4 out, you get 3 on top and 5 on the bottom. We should all agree on that. Now, let's look at x squared divided by x to the 5th. By what we just said a second ago, that should be x to the 2 minus 5. Well, that's kind of a problem because that's x to the what?
Negative third.
Negative third. And that is actually correct. So this is actually 3x to the 2 minus 5 over 5, which is 3x to the negative third over 5. Okay, and that is actually the right answer. However, most people don't know what negative exponents mean. Well, let's think about it. If we hadn't done the plain old regular subtraction, if we'd written it all out like we did before, 12, we would have written the top as x times x, and the bottom would have been 20 times x times x times x times x times x, right? And what would have happened when we did the canceling here, we would have done the same thing with the numbers, but then we would have canceled out one of the x's, canceled out another x, and we would have been left with x cubed on the bottom, right? So the answer would have been 3 on top, 5 on the bottom, and x cubed on the bottom. It turns out that that is exactly what negative exponents mean. What a negative exponent means is you move it to the other part of the fraction. So if you see a negative exponent on the top of a fraction, all you do is move it to the bottom of the fraction and take away the negative. Okay? So 3/5 x to the negative third really means you're really dividing by those x's. So put them down to the bottom and they become positive. All right? Okay. Well, now let's simplify some hard ones. And you might be thinking, oh, that's pretty hard already. Well, they get a little harder. I'm going to take an example right out of the book. This is x to the 5th, y to the 6th, over x to the 5th, y to the 3rd. All right, so everybody think about this. What's going to cancel out here? Now, if you're thinking the x's are the same on the top and bottom, well, that's kind of obvious. Not only are they going to cancel out, they're going to totally cancel out, aren't they? If you cancel those out, they're both going to become 1. It's just like taking 5 divided by 5. So all I really have to do is simplify y to the 6th over y to the 3rd, and I can really just cross both of these out, and we can subtract in our head probably. What is y to the 6th divided by y to the 3rd? Well, it's y to the 6 minus 3, or
y to the 3rd.
Just y to the 3rd. And we're done. That's the answer. Okay? Okay, well, let's let them keep getting a little bit harder here. Let's see, what's a really good one? I know. What if we have r to the negative 5 over s to the negative 2? Well, nothing's going to cancel there, right? Because we only have all the r's are on the top and all the s's are on the bottom. But they both have negative exponents. Well, negative exponents aren't really simplified. What did we say before? If you have a negative exponent, it's where?
On the bottom.
Well, it's in the wrong part of the fraction. So how do I make r to the negative 5th into r to the positive 5? Move it to the bottom. And same thing with s to the negative 2. It's in the bottom now, but if it's a negative exponent, it's in the wrong spot. So move it to the top. So this actually becomes s squared over r to the 5th. So if you see a negative exponent, it is in the wrong place. If it's in the bottom, move it up to the top. If it's in the top, move it down to the bottom. All right, so that begs this question. 7b to the 3rd over 14b to the negative 2. Okay, well, quickly, let's do the easy part. 7/14 reduces to what?
1/2.
1/2, good. Now, the b to the negative 2, it's a negative exponent, so we're supposed to bring it up to the top. All right, if I do that, I'm going to get b to the 3rd, and I'm bringing this b to the negative 2. I'm going to bring it to the top as b squared, and all of this is being divided by 2. Well, this is actually from last night's lesson, isn't it? B cubed times b to the squared is actually b to the 5th over 2. All right, so putting these two exponent laws together, this is what happens with exponents. And again, if you think about what an exponent is, it kind of makes sense. I got one more thing for you. All right, Caitlin. If I take x to the 3rd and I divide by x to the 3rd, whenever you divide something by itself, a banana divided by a banana, how many times do the bananas go into the bananas?
Once.
Once. So that should be 1, shouldn't it? But if I use this rule I just learned, it's supposed to be x to the 3 minus 3, isn't it?
Mm-hmm.
Which is x to the...
First.
Nope. What's 3 minus 3?
Oh, 0.
0. So we've just proved that when you have a variable to a 0 power, anything to the 0 power, anything to the 0 power is always equal to 1, for this reason exactly. So, because really the way you get a 0 power is you divide something by the exact same power of it on the bottom. Okay? So there's 2 rules that you have tonight. X to the n divided by x to the m. What we're going to do with the powers, the exponents, is we're just going to subtract them. Okay? Oops, I'm sorry, I don't want that there. Alright, so that's one rule. Anything to the 0 power is always equal to 1. And there's actually another one that was kind of hidden. Anything to the negative power is really equal to 1 over x to the same number, but make it positive. So here are our 3 rules from this lesson, and we're going to practice those in class. But we're over 10 minutes, so this is probably a good place to stop. So this is Caitlin and Mr. Gunn, and we are signing off. And let's see, do we still have a picture of you? I guess we have the picture from earlier today. I don't think we got to use it before. So while all those people are not in this video, we do have a sunshiny, happy Caitlin in the picture. So thank you, Caitlin, for helping with the video, and hope you all enjoyed. We'll see you in class tomorrow. Good night.